Hi, my name is Evan Wright, and I'm a student physical therapist here at Brenau University, and I would like to welcome you back to another episode of the Cognitive Kinetics podcast. In today's episode, we're going to be talking about nerves, and more specifically, what they are, why they're so crucial for us, and how they impact everything from movement to sensation. So, what exactly are nerves? Well, nerves are a crucial part of the central nervous system, and this system is divided into two main components. In one component, you've got the central nervous system, and then the other main component is the peripheral nervous system. So, the CNS, or the central nervous system, acts as our body's kind of main control center, and it's made up of the brain and the spinal cord, and it integrates all incoming information from our surroundings, and depending on the order of importance, it decides how to respond to the said information. The PNS, on the other hand, or the peripheral nervous system, includes everything outside of the brain and spinal cord. So think things like spinal nerves, peripheral nerves, dermatomes, things of that nature. And the PNS has two main parts. You've got the somatic nervous system, which controls voluntary movements like walking, picking up objects, squatting, pulling, things of that nature. And then you've got the autonomic nervous system, and this controls involuntary functions. So think things like heart rate, digestion, breathing. Think about anything that you wouldn't want to necessarily manually control. So you wouldn't want to manually control your heart rate. You wouldn't want to manually control digestion. Or you wouldn't want to manually control breathing. You would kind of want those things done for you like automatically. So essentially, nerves serve as the body's communication network, and they transmit signals between the brain, muscles, and organs to ensure everything is kind of functioning smoothly. And there are three different types. So you've got sensory nerves, and these carry signals from the body to the brain. So for example, if you're walking down the street and you see like a sign in your path, right? Sensory nerves relay that information to your brain, alerting you about the obstacle. This is when motor nerves then take over, and these carry signals from your brain to your muscles, and this would then direct your legs to stop and step around the object, allowing you to avoid it. But then what happens when, let's say, you need to respond quickly and efficiently to something? This is where mixed nerve comes in. So mixed nerves are essentially sensory and motor signals all in one. So in the scenario of avoiding an obstacle, mixed nerves help you simultaneously sense the object's position and adjust your movements to avoid it in real time. So like let's say you are running and then you just immediately notice that sign. That's kind of where mixed nerves would come in. So they allow for the smooth, coordinated action of perceiving the barrier and stepping around it all in kind of one fluid motion. Nerves aren't just important, they're basically essential to nearly every function in our daily lives. From the complexity of voluntary movements to the autonomic nature of reflexes, our nervous system is constantly working around the clock to make sure that we're moving safe and that we are aware of our surroundings. And we kind of know that motor nerves are the driving force behind every single movement that we make. They carry the signals from the brain to the muscles, and they tell those muscles what to do, when to contract, when to relax, things of that nature. And this complex coordination allows us to do simple tasks like, let's say if I drop my pen on the ground and I picked it back up, motor nerves are telling my muscles what to do just for a simple task like that. Or if I'm doing something more complex like running or jumping, they're telling those muscles what to do when I'm running, what to do when I'm jumping, how fast to contract, how slow to contract, all that good stuff. Let's just consider for a second how many muscles and joints are involved in taking a single step, right? We know that those motor nerves have to send precise signals to multiple muscle groups, let's say in your legs, in your hips, even in your core, to make sure that we're moving very smoothly and very coordinated. And if there's disruption in these signals, be it due to nerve damage or a neurological condition, moving can be impaired or can even be impossible, just depending on how severe or how damaged that nerve really is. Let's take another example of wrist extension. If we're trying to extend our wrist and we have significant damage to the radial nerve, which is the nerve that extends the wrist, we essentially wouldn't be able to extend it, and the wrist would always be in a flex position, and that is actually a condition that's a condition known as wrist drop. And this is where we lose the ability to extend our wrist, and this kind of limits hand function. And these kind of things show how critical motor nerves are for both gross and fine motor skills. Jumping over to sensory nerves, we know that those provide constant feedback about the environment and our body's position within the environment. And this input is essential for making real-time adjustments to movement and posture, just kind of based on things that are happening around us. So they detect things like heat, cold, pain, things of that nature. Let's say that I were to touch a hot surface. In that exact moment that I'm touching that hot surface, the sensory nerves would send an immediate pain signal to your brain, and then that would trigger a reflex to pull your hand away even before you kind of fully process that pain. And that quickness or that rapid response is crucial for protecting the body from injury. And then even beyond just sensing the environment, sensory nerves also give us proprioceptive feedback. And this is able to tell us where our limbs are without necessarily needing to look at them. And this kind of allows us to walk without necessarily having to constantly look down at our feet, or even typing without looking at the keyboard. So let's take, for example, foot drop. Foot drop is a condition that damages the peroneal nerve, and this is a nerve that is responsible for dorsiflexion of the foot. But the key thing about this nerve is that it's a mixed nerve, and if you remember, mixed nerves are sensory and motor. So damage to this nerve would affect muscle control, but it also impairs proprioception in the foot, and that would then make it difficult to walk smoothly and maintain balance. So walking smoothly would come from the motor portion of that nerve, and then being able to maintain balance would come from the sensory portion of that nerve. So essentially, when you damage that nerve, you're essentially damaging two nerves in one. And even though nerves are so important in our body, one of the biggest downside is that they don't necessarily have the capacity to regenerate like our skin cells do, for example. One of the more hopeful aspects is through the PNS, because this has the ability to regenerate. So if a peripheral nerve gets damaged, it has the capacity to grow back within its target tissues, but this is a slow process, and it really depends on a couple of factors like severity of the injury and how quick the medical intervention is. But on the contrast, things like the CNS, which are made of the brain and spinal cord, they don't have that ability to regenerate. So once you damage those nerves in the CNS, they don't grow back. And this limitation poses a lot of challenges for us in treating central nervous system injuries like strokes or traumatic brain injuries. But this is also where physical therapy kicks in. So PT plays a crucial role in neuro rehab because it's able to strengthen the muscles that are controlled by the affected nerves. And this helps in strengthening the muscles by improving coordination and maximizing their function. So let's say, for example, we're working with an individual with foot drop. Physical therapy for foot drop often includes gait training exercises, which are designed to improve walking and address patterns and weaknesses in the foot. And this might involve using assistive devices such as braces, and performing a specific exercises to enhance muscle and control and coordination. And similarly, for an example of like wrist drop, therapy might focus on exercises that strengthen the wrist extensor muscles and improve hand function. And some of the techniques you might use are resistance exercises, stretching, and generally just activities that are designed to increase range of motion and dexterity. Today, we've kind of explored the vital role that nerves play in our bodies, whether it be from controlling our movements and sensations to their involvement in reflexes and proprioception. Nerves are central to everything that we do. And being able to understand these aspects helps us appreciate the importance of protecting our nerves and some of the challenges that arise when these nerves are damaged. In our next episode, we'll dive deeper into proprioception, which is the body's ability to sense its position in space. And we'll kind of dive into how this crucial function impacts our daily movements. I think it's a fascinating topic that kind of ties directly into our discussion today, so make sure you don't miss it. If you enjoyed today's episode, don't forget to follow and subscribe to the podcast so you can stay up to date with all our future discussions. And if you're interested in more neuro and physical therapy content, head over to my Instagram for daily insights and tips. Thank you for tuning in, and I'll see you on the next episode.